Example 3.18. A wire of length 60 cm is cut and bent to form two squares. So let's look at these two squares. The total perimeters of these two squares are 60 cm. So I'm going to let this be x cm. One of the squares is x cm. So the perimeter is 4x cm. How about the perimeter of the other square? The perimeter of the other square would be 60 minus 4x cm. Using the perimeter 60 minus 4x cm, I get one side of the square, which is 15 minus x cm. And we want to find the total area of these two squares. So the area of the smaller square would be x squared. The area of, let's say, the other one, which is green in color, would be 15 minus x squared. So the total area would be x squared plus 15 minus x all squared. After simplification, total area is 2x squared minus 30x plus 225. So we will be using the method of completing the square to find the minimum total area of the two squares. We will be adding 15 over 2 all squared and subtracting 15 over 2 all squared. The first three terms inside the brackets will give me x minus 15 over 2 all squared. The constant term will be 2 times negative 15 over 2 all squared. So I have in orange minus 2 times 15 over 2 all squared, and of course I have my plus 225. Finally, I have 2 times x minus 15 over 2 all squared plus 225 over 2. The minimum area is 225 over 2 cm squared. Part B. Find the lengths of the two pieces of wires when the total area of the two squares is a minimum. Using part A, we know x equals 15 over 2. One side of the square is 15 over 2 cm. How about the other side? The other side would be 15 minus x. The side of the other square is 15 over 2, which is green in color. And that will give us the length of one side of the square. For the square, there are 4 sides, so I have to take 15 over 2 times 4. And therefore, the length of the two pieces of wires are both 30